Hey friends, welcome back for another math lesson with yours truly, Miss Hayman. I hope you guys had a great weekend and are ready to start off the work week with some brain work. So last week we talked all about addition. We talked all about what? Right, addition. Addition is a mathematical operation. Now we learned that addition was about joining numbers. And we know that we're joining numbers when we see a certain sign. Who remembers what that sign was called? Right, Gus the plus. When we see Gus the plus sign, we know that we're going to be joining our parts together. And our number is going to get bigger. You're right. Now, this week, we're going to be switching it up. Say switch it up. Right. We're going to be switching it up and talking about another mathematical operation. Who thinks that they know what the other mathematical operation is that we're going to be talking about? Right. Subtraction. Subtraction is the inverse operation of addition. Inverse means opposite. Inverse means opposite. So in addition, we joined two numbers together. What is the opposite of joining? Let me think. The opposite of joining must be to take away. It's to what? Take away. Exactly. So subtraction is the action of taking an amount away. So today, what we're going to be focused on, or our objective, is to learn how to subtract identical numbers. First, we already went over what subtraction means. Subtraction means to take away. Your turn, get ready, go. Subtraction means to take away. Right. You start with a whole number, a whole amount. And then with subtraction, you're going to be taking one of those parts away. Now, we know that we have to subtract when we see a certain sign. Just like we saw Gus the plus for addition, we see a new sign called Linus the minus sign. So when we see Linus the minus, we know that we are going to be taking an amount or a number away. What we get, or our answer, is called the difference. So today we are going to be seeing if we notice a pattern with subtracting identical numbers. And I know that big smart brain of yours, you're going to come up with the pattern. Now, identical means the same. Identical means the same. And today we're talking about subtracting identical numbers. Identical means the same. It means what? If numbers are the same, that means they are equal. They are what? Equal means the same amount. Equal, get ready, go. Equal means the same amount. Equal, get ready, go. Equal means the same amount. You can see I'm kind of making an equal sign with my hand. When two numbers are the same or identical, that means that they are equal. Now, I'm going to go through our normal trajectory for how we solve subtraction problems. We know that we first start out using counters, then we move to representation, and then we move to mental math. So starting us off, I have 6 minus 6. Another way of saying this is I have 6 and I need to take away 6. So I'm going to use my counters to show this first. My whole number is 6. This is the first number, and really in subtraction, it's the only number you represent. So I'm going to count 1, 2, 3, 4, 5, 6. Now, I see here that I have Linus the minus. So I'm not going to be adding or putting more counters on because Linus the minus, he takes away. So I have to take away this amount. This is 6. So I'm going to take 6 away because that's what minus the minus is telling me to do. Take 1, 2, 3, 4, 5, 6. I just took away 6. How many do I have left now? Right, I have 0 left. I started off with 6. I took that identical same amount away, which leaves me with nothing or 0. 0 means nothing at all. You have nothing left. Now, if I don't have counters, I can represent this or draw this out. When we draw it out, we represent the whole number first. It's our only number that we're going to be drawing or representing. In subtraction, you only represent the first amount. So here I go. Count with me. 1, 2, 3, 4, 5, 6, 7. And I've put my numbers on the inside as my double check. So I know for sure that I have 7 circles represented here. Now I see that minus the minus is telling me to take 7 away. When I take a number away and I'm representing it, I represent it with an X. I'm going to X it out. So let's see how many I have left or what my difference is when I take away 7 from 7. Count with me. 1, 2, 3, 4, 5, 6, 7. 7 minus 7 equals, right, 0. I have no circles that are left. All of my circles have X's in them, which means that all of them have been taken away. So my answer is a big old 0. And 0 means nothing at all. I have nothing. Wondering, are you noticing the pattern? Let's see. Our last step now, once we've realized this pattern, is now I can use mental math. What do you notice when you take away identical numbers? What is the difference? The difference is always 0. The difference is always 0. That means my answer is always going to be 0. Right. So I know now that if I subtract identical numbers, there's no need to wonder. The answer is always 0. Let's try it. 8 minus 8 equals, you got it, 0. It doesn't matter how big the number is. 275 minus 275 is 0. 1 minus 1 is 0. Scholars, when you're doing your work this week, I want you to remember the rule. When subtracting identical numbers, there is no need to wonder. The answer's always 0. When subtracting identical numbers, there's no need to wonder. The answer is always 0. See you next week.